All right, we're back. And in this segment, we're going to talk about brain development. So, at 2 years of age, the child's brain is about 75% of what it's going to be once they reach adulthood, and by 6 years, it's at 90%. So, we're seeing significant brain growth between 2 years of age and 6 years of age. A lot more still has to come, and a lot of the 10% that's left is really the higher order parts of the brain. And so I don't want you to get the impression that all the important brain growth is happening now. That was a really common misconception in the 90s and the early OOs, was this idea that, wow, look how much the child's brain grows in this 4 or 5 year period. Oh, this must be critical brain development, and we better, educate them and do all sorts of things between 2 and 6 years of age that aren't currently being done to preserve all this brain growth. That's probably misguided, because a lot of the brain growth that's going on between 2 and 6 years of age is very much guided by genes and less guided by environment than what will be happening in that last 10% over the ages of 6 years of age. So, all right. So, first off, something that I already addressed in the last age bracket when we were talking about biology is the transient exuberance. Between birth and 6 years of age, we see enormous growth in synapses and dendrites in the brain. So, if you recall correctly, dendrites are the part of the neuron that collect information from the neighboring neurons and from muscles and other from sensory organs and stuff like that. Synapses are the connections between neurons. So we had talked before about how the sensory cortex, the visual and auditory cortex, really is growing fast in the first part of the first year of life, and that the speech production areas are really growing fast in the second half of the first year of life. What's really growing fast now in the 2 to 6 year period is the higher cognitive functions, and that's going to continue on throughout adolescence. And so it's really important to realize that the finer parts of our brain that really make us good reasoners and able to do math and find ourselves in space, knowing whether we're facing north or south, these kinds of things, those are developing really heavily right now, and then fine tuning throughout adolescence and even into emerging adulthood. So rapid growth of dendrites, and by about 4 years of age, what we start to see is pruning. Pruning is where the brain starts to realize that some of these dendrites and connections, synapses, are not really necessary. That we grew too many, and it's time to start pruning them back to more and more accurately represent our experiences. So, on the last slide, I was mentioning how it's probably not great to say between 2 and 6 we should be educating kids really hard and trying to preserve the connections that they're growing, because it seems to be adaptive that we prune excess connections. If you keep them all, you may actually inhibit higher order reasoning. You may actually interfere with healthy brain functioning. It's how the brain was designed, was to grow all these extra connections and dendrites and then prune them back so that your brain is as good at representing the environment as it can be. In fact, one of the explanations for the development of autism is that you have a lack of pruning that occurs between 4 and 6 years of age. So that might be a hint that possibly pruning is necessary, that it's adaptive. So we don't want to necessarily keep everything that we've grown, that's for sure. Now here's something different, myelination. Myelination is the laying down of fatty coatings on our axons. If you recall from our previous discussion of neurons, there's one branching fiber that takes information from the cell body and sends it to the neighboring neurons, or out to the muscles, or other places where the information needs to be delivered. To speed transmission along the axon, the brain lays down myelin sheaths from fat that we've consumed in our diet. So there are certain axons that are already myelinated at birth, and those are the ones that pertain to sucking and swallowing and other life necessary kinds of behavior. But the rest of myelination occurs after birth. And I already mentioned before, can you imagine if you came out with all your neurons and they're all myelinated, how much extra space that brain takes up that you'd never get out of the birth canal? So we have to do a lot of this brain development after birth. So myelin is fatty tissue that serves as an insulator for the axon so that the electrical impulse that's going to travel down the axon stays on that axon until it gets to the end, where then it can trigger those chemicals to be squeezed out of the end of the axon, float across the synapse, and lodge in the dendrite of the receiving cell. So when we have myelinated axons, we get quicker reaction time, we get faster thinking, and we have quicker access, better, more accurate access to our stored memories. So across this time period between 2 and 6 is the most heavy time for laying down myelin. So it's really super important during this period of time that we don't limit fat in the diet of toddlers and young children. They need the kind of fat that comes in, for example, whole milk. Or when they were nursing, it was in their mom's milk, the kind of cholesterol that's necessary for forming myelin. So babies need this kind of, baby toddlers, small children, they need this kind of cholesterol. The kind of thing that we avoid as adults because it might start making, clots and whatever in our veins. It's what we need for the developing brain between birth and about 6 years of age. So all the things that we as adults might want to avoid because it's too high fat of a food are the kinds of things that babies absolutely need. So it's actually a good thing to be a fathead, right? You want to have a lot of fat on these axons. Now we know that this is true from studies of children who have been deprived of fat. Maybe they're living in a famine region, and so the food that is brought oftentimes has to be very shelf stable and oftentimes is low in fat. It might be just a child subsisting on rice, something like that. And what they find is that the brain of the kids who are between the ages of birth and about 6 years of age have less myelin, fewer of their axons are myelinated or myelinated as thoroughly as those peers who were not during that age bracket facing a famine. So once you lay down the myelin sheath, it'll stay there. It's not like you don't burn this kind of fat like you would subcutaneous fat. If you're experiencing a famine, you'll burn the fat on your abdomen or your thighs or whatever, or on your organs. But you don't burn this fat that's in your brain. It's in there and it's done, and it'll stay like that. And so if the myelin was laid down before the famine started, the children were not affected. If the child was supposed to be laying it down during the time of the famine, then you see lack of myelin, and then you see symptoms as a function of that. You may see, if it's bad, you could have a kid whose motor skills are impaired for the rest of their lives. They don't have as good a control over their bodies, or they have speech problems, or just if it happens later in their developmental period, if the famine happened later, you may have lower IQ, just sort of generalized. They have difficulty, solving math problems or reading or other things that are part of IQ testing. And it's permanent. If you miss this window of opportunity to lay down the myelin sheath, you miss the opportunity. And so it's not something that you can go back and remedy later. So that's why it's really super important for adults who live in, a country where you have access to these things, not think thoughts like, oh, I knew somebody once, believe it or not, I actually knew a mom. This was a story from back in the 80s, who was trying to limit her 1-year-old's fat intake because she thought that you put on fat on your body after birth, and if she could avoid her toddler from laying down fat on her body, then her whole life she would be thin. And when I suggested to her as a good psychology student, I said, I am pretty sure that the location of fat and the amount of fat cells a person has is determined by genes, and that was taken care of back in the womb. She didn't really want to hear much about that, and when I argued that she needs the nutrition so that her brain will function properly, she didn't really want to hear that either. She was much more focused on her child never growing up to be fat. That's hopefully not a common attitude. I hope not a lot of moms have that attitude, or dads, but the fact that I met a person who felt like that makes me think it must be something people think, that you can lay down fat in your diet as a child. So hopefully I can disabuse you of that belief if you think that's true, and focus in on, brain health. It's really important for children to have adequate fat in their diet so that their brains will be as healthy as they can be. Which brings us to development of motor skills, right? You want to have your motor strip all myelinated up so you can start developing your gross motor skills. Now, we talked about this before when we talked about infants, because infants are pretty much all they have is gross motor skills. Now we're moving into a period of time where they may have, they're going to continue developing their gross motor skills, and then also we'll talk a little bit about fine motor skills in a second. Just to illustrate how they change in such a short amount of time, I'm going to show you 2 quick little silent videos, and you can kind of see, the little kids versus the older kids. Now this might make some noise, so I'm going to mute myself so you don't, hold on a second. Well, let's see what happens. I don't remember. I'll go ahead and unmute it. I don't remember if noise is going to happen or not. All right, so here we have a little child. I don't know these kids. I got this off the internet, but I'm going to guess by the proportions of the body and stuff that we're probably talking about somebody who's no more than 4 years old in this video. So let's check these motor skills. Oh, it has music. So see what they're working on. Stamp your feet, run around, touch your toes. Put one foot on the ball, then the other foot on the ball. So this is an advertisement for some soccer camp that you can put your kids in. So you see what their motor skills were. Now let's compare that to just same age bracket we're talking about. So now we're looking at 6-year-olds. So let's check and see how much, probably in just 2 years from the last video to this one, you can see changes in their motor skill, their gross motor skills. Okay, now, full disclosure, he's the best soccer player in the U.S., they say. So apparently he's 6 years old. Okay, I don't think those kids in that last video could do this, right? Bounce the ball off their foot consistently and follow it around with their one standing foot had to be moving to adjust for the kicking. Watch this, right? Didn't trip himself though, got his foot out, right? So look at and all of his peers. He may be the best soccer player of his age, but look at how everybody can run better, can kick out one foot. These are what we call gross motor skills. So we have this change that has occurred between, 2 years of age, where I couldn't even find 2-year-olds playing soccer, right? To the age of 6, where they can play decently competently, right? They can run, they can kick, they can do all of these things. These improvements that we're seeing are due in large part to brain changes, right? Like the myelination, the development of the synapses in the motor cortex allow the person to actually have better control over their body as they get older. And then, of course, practice and experience. So if your 4-year-old was in that first video going to camp and learning these little basic skills, stomp your feet while sitting down, stand up and jump from one foot to the other foot, like these little skills that they were picking up to sort of improve their gross motor skills, that kind of practice, that kind of experience will help them to connect the neurons in their motor strip so that they can get better and better at playing. Just to give you a foreshadowing of cognitive development, which is the next chapter, part of it, practice and experience, is not just getting better control over your body with these motor skills, but it's also about predicting what's likely to happen next and those kinds of things that'll actually improve performance as well. Now, fine motor skills are just really starting to develop during the 2 to 6-year-old period, where kids can start to manipulate smaller objects. So these are little kids, maybe 3 years old, and you can see that they're playing with Duplo blocks, not Legos, because that's too small for them. These are little kids who need to manipulate, with their fine motor skills, they need to manipulate larger objects than they'll need to do, later. But right now they need to have big enough things that they can grasp. You know how they have the thicker crayons for littler kids because they break them too easily because they don't know how much pressure to put on it and how much to lean on the middle of the crayon and stuff like that, right? So these fine motor skills, just like gross motor skills, are going to develop across childhood with better and better control over these little fine muscles that are the fingers and the thumb. To a certain extent, toes fall under fine motor skills as well. All right. Well, that completes the big basic stuff. I'm going to say that, our textbook talks about other things having to do with malnutrition and neglect and things like that. I just wanted to hit the high points of the big goals and milestones that are being achieved during this age bracket. So I will see you guys next in the chapter on cognitive development in the 2 to 6 year old. So see you then.